So saya hari ini sebagai moderator untuk sindiket 1. So kita ada 2 tema, dasar awam dan tadbir urus dan keselamatan dan teknologi makanan. So dalam sesi sindiket 1 ini kita ada 5 pembentangan. So untuk pembentang saya just nak jelaskan pembentangan untuk 20 minit. Selepas habis pembentangan, so kita ada 5 minutes Q&A. So Q&A ni selalunya macam satu atau 2 soalan lah. Okay. So untuk yang para hadirin, sila scan attendance, ada kat depan, ada QR code tu. Dan untuk esok just nak remind semua orang, kita akan start pada pukul 8.45 agenda apel. Okay, so tanpa melengahkan masa, saya menjemput presenter Dr. Munira binti Abdul Zali. Tajuk pembentangan adalah Assessment of Sewage Contamination Using Chemical Markers and Nitrate Stable Isotopes in the Lingi Catchment, Malaysia, a potential novel input into Malaysian guideline. Silakan Dr.
Tak payah tutup. Tak payah tutup. Okay.
Oh, tak payah tutup.
Hello. Assalamualaikum dan salam sejahtera kepada audiens di Banquet 1 Intan Bukit Kiara. My name is Munira binti Abdul Zali. I'm from the Waste Technology and Environment Division, Malaysian Nuclear Agency. Today I would like to present my research title entitled Assessment of Sewage Contamination Using Chemical Markers and Nitrate Stable Isotopes in the Lingi Catchment, Malaysia, a potential novel input into Malaysian guidelines. As introduction, we know that aquatic system worldwide is under increasing anthropogenic pressure, which is the anthropogenic pressure may come from the sewage pollution. This sewage pollution may due to derive in aquatic environment and may cause to they are resistant to environmental changes. And these techniques, this research is using the sterols and stanols to assess the sewage pollution and also incorporate with the hydrochemistry and also stable isotope, which is we know as delta 15N nitrate and delta 18 oxygen nitrate. And for problem statement, this Lingi catchment is actually a very important source of water source in the Negeri Sembilan state. This Lingi catchment is actually located in the middle stream of the river. So can you imagine all the pollutants from the upstream of the river goes into the middle stream and then pass through to downstream. So there is a lot of activities of in the upstream of Lingi catchment. They may cause the deterioration of the water quality at the Lingi catchment. So the study objective first is to determine the distribution of sterols and stanols in selected sewage treatment plants, river water and groundwater of Lingi. Number 2 is to investigate the source of sterols and stanol in the STP, river water and groundwater. The third one is to identify the hydrochemistry and isotope composition of nitrate in the water sample. And number 4 is to evaluate the potential sources using all these markers. So as I mentioned previously, this is the Negeri Sembilan state. So this is the Lingi river here. So this is where the water source located, where the Syarikat Air Negeri Sembilan take the water from the Lingi river here, process it and become our drinking water. So in this basin, there is several anthropogenic activities. Anthropogenic means the human activities. So there is industrial area, this is Seremban and Senawang area. So can you imagine there is a lot residential and also urbanization area here. So all these pollutants goes to this source of water and then goes to the downstream towards the Straits of Malacca. So in this study, the sampling was conducted during the rainy and also dry season. And this is the location for the river water and groundwater here. Groundwater 1 and groundwater 2, here, 3, 4, 5, 6. So this is the land use type according to the sampling station. And there is several of sewage treatment plants along this river. So for materials and methodology, because this study is using chemical markers, so I'm combining the sterols and stanols. This is the chemical markers. This is actually the compounds about 400 plus molecular weight. So, and then analyze also with hydrochemical parameters such as the nitrate, chloride, phosphate, sulfate, calcium, sodium, magnesium, and also you analyze the nitrate stable isotope. So for sterols and stanols, there is two phases, filtrate and particulate in the water sample. So extract the water sample, extract it and analyze using the gas chromatography mass spectrometer, which is the GCMS. And this hydrochemical and also nitrate stable isotope is using, for hydrochemical using the standard established method, and also for the nitrate stable isotope is using the ion exchange method and analyze using the elemental analyzer isotope ratio mass spectrometer. And then for this is the result for the first objective. The first objective is to determine the distribution of the sterols and stanols. So this is the distribution of sterol and stanol based on the compound coprostanol, epicoprostanol, cholesterol, cholestanol, campasterol, campastanol, stigmasterol, stigmastanol, beta-cytosterol, cytostanol, 24-ethyl coprostanol, and 24-ethyl coprostanol. This is actually markers. This coprostanol is a marker for the human, and this is epicoprostanol is the marker for the sewage treatment plant. So if this compound exists in the river water, so there is actually a discharge of sewage pollution into the river water. For objective 2 is to determine of the chemical markers, which is the sterols and stanols, using two techniques, which is diagnostic ratio and also principal component analysis. So from diagnostic ratio, we can know which of the sample is impacted with the treated sewage, partially treated sewage, and also raw sewage. And based on the second technique, which is the principal component analysis, this is the statistical method. From the statistical method, I did interpret it as three sources, which is treated sewage and partially treated sewage, based on the compound and also the variability of the chemical markers. And also the third source is the raw sewage. So this result in discussion be published in the Journal of Environmental Science and Pollution Research, published by Springer. So for the third objective is to determine the hydrochemistry, which is the calcium, cations and anions. The cations is calcium, sodium, magnesium, potassium, iron, and for the anions is chloride, this one, chloride, phosphate, sulfate in the water sample. So there is different of this abundance of this hydrochemistry during the dry and rainy season. And also we can notice that alkalinity is the most prominent parameters in both seasons. So because this study is emphasizing on the nitrate, so we analyze, we zoom into nitrate concentration in the river water sample, because okay, this is river water 1, river water 2, river water 3, 4, 5, 6, the concentration of nitrate during the dry and rainy season. This river water 1, river water 2, river water 3 is located at the downstream of the river. the nitrate concentration is higher than the upstream level. So we can conclude that the nitrate may derive from the upstream towards the downstream, and also the nitrate may come from the terrestrial sources, may come from the land use at this area, such as the palm oil and rubber plantation, and also sewage pollution, manure. These pollutants can contribute to the nitrate distribution in this downstream part of the river. So after analyzing the nitrate, we use the technique nitrate stable isotope, which is analyzing the delta 15N nitrate and also delta 18 oxygen nitrate in the water sample. This is actually a cross plot that been used worldwide. So there is two plot here for the oxygen and also nitrogen of nitrate. So this is actually the worldwide database, the range for atmospheric nitrate, sewage manure, ammonia and fertilizer, soil ammonia and also nitrate fertilizer. So we can see here that the river water sample was mixed with the various type of nitrate pollution sources. For example, the station river water 4 and 6 here, there is a lot of residential area here was impacted with sewage, manure, and also the soil ammonia and ammonia in fertilizer and precipitation. We remember that the nitrate also may derive from the precipitation and atmospheric nitrate, because our rainwater contains lots of nitrogen. So for the objective 4 is actually to assess the potential sewage contamination using all the markers, which is the sterols, stanols, hydrochemistry, and nitrate stable isotopes. So because dry and rainy season may have a different type of sources, nitrate pollution sources, so I did analyze all the markers based on the dry season and also based on the rainy season data. So during the dry season, from the principal component analysis, the source of pollution is solid enrichment, surface runoff, raw sewage and domestic waste, the mineral dissolution, and also fertilizer waste. For rainy season, there is additional of anthropogenic sources, which is solid enrichment, raw sewage is prominent during the rainy season, herbivore fecal contamination, treated sewage, geogenic sources, and terrestrial runoff. So why terrestrial runoff is also part of rainy season? Because during the rainy season, the surface soil of the terrestrial area around the river, surrounded by the river, may goes into the river water. So based on the absolute principal component analysis, and also I did some sensitivity analysis, this is the percentage of pollution during the dry and rainy season. So from the dry season is about 80.2% of solid enrichment. But this percentage reduced during the rainy season to 68.7%, because during the rainy season there is a lot of other inputs into the river water. So for study significant, the assessment of sewage pollution status in this river is very important, because this river actually supplies to many areas such as the Seremban district here, Senawang, Port Dickson, and nearby area. So this river is actually important water source. This is actually a very unique river. Why? Because this water source located in the middle stream, while in other states, the water source is actually from the upstream and also from the lake, from the very pristine area. But this river, we take the water source in the middle stream of the river. So we need to protect this river because it is actually a water source for the citizen in this area. The river and groundwater monitoring provided by the local environment agency, they only monitor for certain parameters such as the biological oxygen demand, dissolved oxygen. So some of the parameters cannot provide what is the source, what is the specific source for this river, what is the specific pollution sources of the river. So that's why we need to use multi-marker techniques, involve all other markers to understand what is going on in this river. So this study further enhanced by investigating the stable isotope. This is actually modern techniques to assess the sewage pollution, and it has benefits for the protection of ecosystem, environmental conservation, and also the drinking water source. So the research findings and implication in the government policy. For my study, it is give implication towards the current environmental agencies such as the Jabatan Alam Sekitar Malaysia, which is the Department of Environment Malaysia. As I said previously, the current monitoring of the river is only based on this parameter, which is the ammonia to nitrogen, biochemical oxygen demand, chemical oxygen demand, pH, dissolved oxygen, and then based on these 6 parameters, they calculate the water quality index to classify the river. Let's say the river is, the calculation of water quality index is more than 92%, maybe categorize the first class first, which is the class that clean, pristine. But for this one, the class 5, if the water quality index is less than 31, so the river water is very polluted. So based on this index, we just only know the numbers, but we don't know what is the source of the pollution, what actually we can do. So we need information, more information of the chemical markers to combine all the possible, the index and also the chemical markers to understand what is the source of pollution in the river water. And also this study also benefit to the Syarikat Air Negeri Sembilan, which is this syarikat is the water treatment company. They take the water source from the Linggi River and then treated it for the use of the Negeri Sembilan state. So by examining the sources of pollution, we can tell them what is actually happening in the Linggi River, what is going on, what is the most important parameter, what is actually type of pollution. So we can tell them what is going on in the river. So also our kerajaan also terus perkasa pengurusan air dasar, air negara menjadi dasar air negara. We have a lot, we have to really take a look in the dasar air negara. And also this is also part of the Sustainable Development Goal, which is the number 6, which is the clean water. And also recently, government, which is the Rakan Strategic with ASM, also have lembaran fakta transformasi sektor air, which is in year 2040, on the transformasi sektor air in 2040. So based on the 2021 year 2021, 27% of sungai of jabatan telah dipantau oleh Jabatan Alam Sekitar dinyatakan mengalami pencemaran ke atas kualiti air berbanding pada tahun 2017. So even though there is a reduction of the number of polluted river, but we need more information on the what is actually pollution sources, what is happening in the river. We cannot just rely on this index alone. This index is very good, but we don't know what is the source, what is the type of pollution sources in the river. So by knowing what is the pollution sources, we can do the mitigation action and further conservation of the river. So thank you for listening. That's all from me. If you have any questions, please contact me. This is my email.
Okay, terima kasih Dr. Munira. We have 5 minutes for Q&A. Do you have any questions to Dr. Munira? Yes, please.
Assalamualaikum Dr. Munira.
Ya, waalaikumsalam.
Thank you for your presentation. I just would like to ask about when you kita tengok pie chart tadi kan, the biggest area is actually the solute enrichment. Could you elaborate a bit about that? And also you were talking about fingerprinting tadi. Would it be the ability untuk nak check the sources tu to the extent that kita tahu lah daripada ladang ayam ke, daripada ladang lembu ke, to what extent can we check? Sebab kerajaan tempatan kalau dia dapat tahu itu, dia boleh buat dasar untuk tidak membenarkan serta-serta industri untuk berada di kawasan itu. Terima kasih.
Okay, for the solid enrichment, okay, this is solid enrichment is based on the parameter of calcium, potassium, sodium, fluoride, nitrate. This is mineral ions enrichment in the river. Why it's named as a solid enrichment? Because due to various type of source, which is anthropogenic and also natural sources. But because the nitrate also high, we can say that the solid enrichment for these pollution sources during the dry season is due to the anthropogenic sources. Am I clear? Or that one for the second question. Okay, actually for using the sterol and stanol, okay, from these slides, okay, for STP, there is patterns for coprosanol, epicoprosanol, cholesterol, and also if there is patterns, the patterns is similar with the river water, we can say that the river water is coming from the sewage treatment plant. So then we need to analyze the source of, for example, chicken, cow farm, or other type of animal farm. And then we need to analyze this sterol and stanol, get the patterns. And if the pattern is similar to the river water sites, the area, so we can conclude that the river water was impacted with that animal farms. It's basically on the distribution and also ratio. You can use that technique. More question?
So we have another 2 minutes. Any questions, please?
Assalamualaikum Dr. Munira, I'm Shohaida, I'll be the 5th presenter. It was a lot of jargons, I totally feel like I'm alien in this room. Okay, by the way, I have a very simple question. Can you go to your slide number 7? I just wonder, here, 7 please. Okay, here on the right, you show that the WHO guideline is as per red threshold. So I just wonder, based on your data here, all the bar chart is even lower than the WHO guideline. So how significant is your research contributing to our local expertise or local practices? If we look at this, it's not that significant. So
Yes,
can you
correct,
please give comment on that? Thank you.
Yeah, the guideline for the World Health Organization for nitrate value is 50. But even though the value for the river water sample is lower than the WHO guideline, actually we can see the increasing pattern towards the downstream, from the upstream towards the downstream. So there's a concern to me, because usually nitrate is easily dissipated in the water, but the pattern shows that from the upstream here, this is the station upstream, the nitrate concentration is increasing towards downstream. So it is a concern actually, because nitrate, if the high amount of nitrate may cause a lot of eutrophication and also the blue baby syndrome, the health effect because high value of nitrate. So even though the value is low, but we need to find what is the sources so mitigation action can be done in future.
Okay, so we thank you, Dr. Munira, for your presentation. I really appreciate the effort, and you have shown us a lot of implication, and I really appreciate for the publication. That's a good publication you published in Springer, right?
Yeah.
So congratulations for that. So all the best for your future.
Thank you.
Okay, so let's give a big applause to Dr. Munira.